Hello everyone, and in this video today, I will continue with our series with the VDBs. And in the last video, we created volumes with the ISO offset node. But in this video today, we will continue with VDBs, and I will tell you what VDBs are, how they are important, and how they are different from the volume we create through ISO offset SOP node. So without wasting any time, let's start with the video. And as always, I have created some notes for you and we will review them while we move with our video. So first, let's create a geometry so we can have our volume inside the geometry. Let's say I want to create a sphere. I have this sphere, right? And I have some nodes here also. We will review this, but first, right now I have this sphere. So in the last video, we created our volume through this ISO offset node. We have this volume right now, and in the last video, I explained like in detail what is volume, what are voxels, and in this video today, I want to start with VDBs. So now this ISO offset node is creating voxels of this sphere, and these voxels have a density attribute, and each voxel has this density attribute values, and our renderer is converting like those values into the fog. I explained this in the last video, so let's focus ourselves today on the VDB part. So we created the volume through this ISO offset node, but let's create this same volume through VDB node. So VDB from Polygons. But first, what is this VDB? VDB is volumetric database. It is type of a database. It stores voxel data, but it is more like, how do I say, more computer friendly. So it's a smart way to have to store data. What is the main difference here? This ISO offset node is creating voxels in this volume bounding box, but these voxels are everywhere inside this box. Here, each corner, every part of this bounding box has voxels. So those voxels have density value 0 because you see there is no fog here, but you see the fog here. And these voxels which have density value 0, that means we don't need that density value on those voxels because our density is here. We need our sphere to be converted into the fog, but these voxels have also the density value which we don't need. So it is like occupying a space. We don't need space in our storage, it also requires some more computing power. So to get rid of this issue, we have another type of volumetric database. This is creating a this node is creating like a database, voxels with density values. This is also creating a database, voxels with density value, but it is creating only those voxels with the density value which exist on this geometry, not at this part, not at this part. So it is a smart way to have to store the data. So I have created a note about this, and we will review this note by, I can zoom this out. So VDB is a smart lightweight volume format. It stores only the voxels where the data actually exist. We have the voxels, and each voxels have a density value. You see, this sphere has voxels inside this sphere. So it only stores the voxel where data exists. VDB volumetric database, volumetric 3D data, smoke, fire, fog, SDF database, an efficient way to store that 3D data. Tell you something else, that this type of database we call sparse. So sparse is a type of database that only stores the attribute value to those voxels where the value that where the value exists. So as I wrote it here, a volume that stores data only where something exists, does not store empty spaces. These empty spaces voxels don't store, do not have the density value. So we are now how can I say that? We are now saving our computing power, and we are saving a lot of RAM in this. That's why it's a smart way to have our data. So we have these are same, but you would see here what is happening here. In the last video I talked about signed distance field, right? The signed distance field values in the last video, and now it is displaying that field. Right now we see this. So these are voxels whose signed distance value equals to 0, because in the last video I talked about this topic. The positive sign distance values are here. The voxels with the positive sign distance value on the surface are those voxels which have the sign distance value 0. Inside that we have the sign distance value negative, and we have the VDB type. Distance VDB is surface. We can toggle this off and toggle this fog VPT, which is our density. This is creating our density attribute. And I have voxel size. We can increase or decrease the voxel size. You see, you can decrease the voxel size, and you see we have much more detail. So it's like pixel, right? In the last video I talked about this. So we have this VDB. We can visualize this. So we have VDB visualize tree, and when you connect this to this, you would see something like this. So these voxels are only exist where we need this density attribute values, not in this space, not this in this space. So it's a smart way to store our data. We have ISO offset, but we don't have any way to visualize this. But we can visualize this by creating our own way. We can create some cubes. We can create some boxes and copy to those points where we have our voxels. So I want to talk about we have this offset parameter, and I want to first talk about what does this offset parameter do. So we have our SDF volume, right? So when we offset this, you see it is moving in space. But I want to tell you here something, that these voxels have SDF value 0, right? And when you offset this, so we are now translating these voxels which are on the surface with the surface distance value 0. We are moving them. If we offset this in the positive direction, then they are translating into the, let's say, positive direction outwards. And when we, let's say, in negative, so now they are moving in the negative space, inwards. So it is now covered, let's say 0. And let's create our voxel visualize tree for this also. So what we need, first we need a box, right? We need this box so we can copy, but we need those points also. So as we had attribute VOP node for the polygons attributes, right? For volumes, we have volumes VOP node, which acts on attributes of the volumes. So let's create our volume VOP node, and when I connect this to this, so now it is working on this ISO offset voxel. It, like the attribute VOP node, works on the points of the geometry, but here the volume VOP works on the each voxel, so you can control voxel's attribute, right? So inside this, you see it is already connected to the density because and when you created that attribute VOP, it was not connected to anything because we have different types of default attributes there, right? But in this case we have only one density attribute because voxels have like only they can have a few attributes: density, temperature, and 2 and 3 more. I will talk about them, but to not make you confused with a lot of these, I will just say the default is the density. There is only one port here, so there is nothing else, and we have this density, and density is already connected to this density VOP because we have the density attribute already exist here. So this ISO offset node created a density attribute which exists on each voxel. So now we are now modifying that density attribute. You don't need to think about this a lot, just say it is already connected. In that case it was not connected. We don't need to worry about this, right? So let's create our points. First I wanna say this fog volume, and here inside this let's create our points. To add points, we have this add point VOP node, and we have this PT value. So what is this PT value? First I want to show you something here. When we create this add node, you see something right here, there's nothing. But when I give this PT value, so PT value is something like it expects a value. It is saying like the points that this is creating, they expect a value. So what attribute like they would have? So this PT value expects an attribute, and this PT value is like something like we are creating new points and those points need something on them. So that's it is asking for. So the new points would have something and we have to give that something. So if I give this a constant and constant to this constant, what if I say I want a vector and I want this position vector? So I am giving this PT value a position vector, so it can like have a position to be created on. But here I want to tell you something. This VOP, volume VOP, works on each volume. It calculates for each volume. What do I mean by that? When I created this add point, so it's not like we are adding the points on this 3D space. No, we are adding this point to now like each voxel. It is working, it is calculating for each voxel. And when you give this a value, you would see a point. And where is that point? Because we have this P, let's say 0, 0. There should be a point. Why we are not seeing a point here? The point exists. And how can I tell this? Because when you connect this to this, okay, we have to give this yes. You see here it was not toggled on. So inside this we have this PT value. So this point we have given this position a vector, and it's the position vector is converted into is connected into the pt value. That means this pt value is now have a value, a place to be to like create points on. But we only see one point. This is not one point. These are all the points for each voxel, but they have a single position for each point of the voxel of each voxel. But when we connect this to this, we see each point for each voxel. So this is our voxels, and these voxels, now this add points is like working on each voxel. So it means we are creating a point for each voxel. I hope you understand this. I don't want to waste our time like in like going into detail, but you get the idea, right? And we can create an attribute VOP node. So we can now I want to give these points are p-scale value. And how we can do that? We can do that by wrangle, and we can do that by attribute VOP, or we can create an attribute create SOP node. But I want to make this simple, so I just want to like show you how this works. So you don't need to like dig deeper into this, but it's nice to have the idea. So attribute VOP, we have worked with this a lot. We need a bind export to export the data, and we need the data, but from where? We need the points data. So we need the points position. We have this volume VOP3, and we need what if I want this to be p scale. So I am giving each point a p scale value, and each voxel size would equal to this p scale. So what I want to do here is I want to give each point the p scale value equals to the voxel size. So when we increase or decrease the voxel size, so we can have the point scale value same as the voxel size. What do I mean by that? We have the input one, and input one is coming from this. So we have the attributes that is coming from this, but we need to tell this which attribute. And we have two types of attributes. First intrinsic, second extrinsic. And here just I will tell you something, like just remember this. If attribute, you can see here when you create p scale, this p scale, you can see it here. That means it is extrinsic. And what is extrinsic? Extrinsic is like which users can change. Users can play with, like CD, you can change it by your hand. Intrinsic attributes are like working behind the scenes. When you like work with something, those intrinsic attributes change. So it works on background. That's why we call those intrinsic. I want to tell you something. You don't need to worry about this right now, but just remember this. Voxel size is intrinsic because it works behind. You cannot change the voxel size, but here is a very important thing I want to tell you. We created this ISO offset node, right? And we have this voxel size. When we created this VDB from Polygons, we have this voxel size, and you are not changing the voxel size from here. What you are doing? You are telling Houdini that create a volume with this voxel size. You are not like changing existing voxel size. You are creating a volume with this voxel size. Just remember this. Voxel size is intrinsic attribute. So when you come here, right, so you have to say primitive and intrinsic. So this reads the intrinsic attributes from this input one geometry, and I connect this to in the p scale. So now these p scales, these points have the p scale attribute, which is equal to the voxel size. So when I turn this on, these points have p scale values, which is equal to their voxel size. And I create a box and copy 2 points. We see something like this. When I turn this on off, we see something like this. So each box represent a voxel, because the point p scale values was equals to voxel. And have I told you how p scale works? I guess I have, but I will tell you again. So we have the box native value, we have the box native scale, it's size 111, and when I copy this box onto a point, right? So if this point has a p scale value, this p scale would multiply with this initial value of this box, right? The original value, and it would give our the like what's the word, final value, right? So p scale multiplies with the original value and it gives us a final value. So when you decrease its size, what is happening here? Now the p scale, let's say, have the voxel size, let's say, is 0.5, and you are saying that the p scale, the box original value is 0.1. So this 0.5 and this 0.1 is now being multiplied and we are getting the result. So you have to give this 1 so we can have the value of the voxel, because when you multiply 1 with the p scale values, which is equal to the voxel size, you would get the exact voxel size scale of this box. So when you say wireframe, you would see something like this. Each box represent a voxel here. You see this ISO offset node is creating voxels on this whole volume bounding box, but this volume was creating only at those where the volume density exists. And you see this blue, we need these because there are fine density scales, so we need these. And I have this. So when you increase or decrease the voxel size, this would change by the same. And I have created some nodes. Voxel size is an intrinsic attribute. Why? They are built internally. You cannot see them in the geo spreadsheet. First, VDB voxel size control. You are not editing the existing voxel size. You are telling Houdini, create a new VDB with this voxel size. ISO offset shifts the zero distance. I told you about this offset. And we have the sparse. And okay. Now what I want to do here, I want to get in a detail. I want to be more specific. I want to create something here. Let's create our test geo rubber toy. And what you can do, you can say VDB from polygons, and polygons, you will see something like this. Smooth. Okay, we have this, and you can toggle this distance VDB. It is creating the sign distance field values. We don't need this, we need the density values. The fork VDB name density. Density is a name of this attribute, like p scale, right? So density is like p scale. It is an attribute name. It's not a random text. Here Houdini density means this density attribute. So we have this voxel size, and I want to decrease this voxel size to 0.1. You change this by accordingly to your system, because when you decrease the voxel size, the calculating time increases because it requires more computing power. But here I think it would be okay if you give this something like 0.02 or 0.03. But to visualize this, I want to create this, and we have this node, volume visualization. Volume visualization node, and what it does. First, I want to tell you this. This volume visualization is only for viewport. Is only for viewport. If you render this, it would not look like this. It would look like something like this. First, you have to like give this texture. So do not worry about this. I will tell you the render and the texture in the next video. But for this video, just remember this volume visualization is a way so we can visualize our volume like better, in a better way. So when you say ambient colors, so you see the dark areas, you can change the occluded colors. And what do I mean by occluded colors? You have ambient occlusion, right? Just increase the density scale, you would see something like this. So ambient occlusion is like how, like if you have a surface, right? You have a surface connected, and here there are some shadows. So to see them, we have this ambient occlusion that like makes it easy to visualize the object we are working with. So we have volume visualization. Occlusion color, occluded color is like the ambient occlusion color, and you can change that occlusion color, the bright and the dark color. So here the occlusion is the dark color. You can say something like this. So the dark color, the how do I say that? The dark area would have this color, It's just a color, it's a visual representation. And when you are increasing the density scale, so when you increase the density scale of these voxels, you would see much more denser like fog, because we are increasing the density scale. But here I want to tell you something, that this only happening in the viewport. It won't happen in the when you render this, but then you have to give this like a texture, like a material. So you don't need to worry about this. Just say this volume visualization is a way. And I have talked about the what do I say, the why it is getting darker when we scale this in the last video, because of the light. The light has to travel more of a distance. So when it travel more, then it would like scatter, it dissolves, right? It breaks. So that's why we see these dark. Okay, for this video, these two volume visualization is only for viewport, and this VDB, we are creating this VDB, which is a sparse smart way to like store our data. Now what I want to do here, we have this VolumeNoiseFOG. So we have two volume noise. We have this VolumeNoiseFOG, we have this volume noise SDF. SDF works on sign distance field, but this fog works on this fog field. Like SDF, right? I have created the SDF, explained as SDF. Now for this video, we have this volume noise. So volume noise is a general noise you can apply to this. And I have talked about the noise in my noise video, and we are getting the values. And now we have this operation and range values. So operation, we can multiply the noise by the density value. We have different types of operation. We can add, subtract, multiply, minimum and maximum. So minimum and maximum, you don't need to worry about these because we will cover this like gradually. We have the amplitude, you can increase or decrease the values, and output row, I will explain this like later. If I explain everything right now, you would get cluttered with the information. And I want to tell you here something. If you want to like really learn these concepts, then pick one, like learn about it, and like uh, learn what it do, how it works behind why it gets its name. So here we have these noise types, element size, offset, right? We have this animation tab also. So for this video, just remember we have the multiply, add, subtract, and we have these types: positive, negative, range values, like positive from 0 to 1, negative from 0 to like in the minus, we have 0 centered. And for this video, just remember this 0 centered. You know, positive, negative, minimum, max I will cover in the next video when we create clouds. 0 centered. Okay, what is 0 centered? So I have created a note about this 0 centered. When you create the 0 centered, right? So let's say you have a range from 0 to 1, right? You know about fit range, right? We created that fit range, we talked about fit range. So it's like changing the values from one range to another range. And 0 center is like doing the same, but it is centering those values around 0. Same in positive, same in negative. Some values would be negative, some values would be in positive. For example, you see something like this: 0 center range, original range, its midpoint, minus its midpoint. So what I'm trying to say here, if original range is from 1 to 2, 0 center range midpoint, it would calculate it midpoint and original range minus midpoint. So original range 1 minus 1.5, which is its midpoint, 0.5. So our 0 center range would be minus 0.5 to positive 0.5. For this, just see what is happening here. So toggle the display on and change the density. You would see something like this, right? It is 0 centering. And why we are seeing these like voxel density are getting faded, because the values that are coming from this are negative, are in positive. So when you add or when you multiply those values with the positive or negative values, you would get some density values which would be 0, right? For this add, and you will see something like this. Now these voxels density are getting 0, that's why we are seeing no fog. You can increase or decrease the element size. So element size is like how the fog, how the noise would be on this, how large or small it would be. Noise are like random numbers scattered in this 3D field in a pattern. So we are looking something like this, and you can increase or decrease the element size. This looks okay. And what you can do here, you can offset this. Like offset is like changing the noise pattern, like you are offsetting the noise. If the noise present here, you are offsetting this something like this. And we have this animation. You can turn this on, you can increase or decrease the pulse. When you play our animation, you will see something like this. So it is now changing the values are animating. We don't need to worry about this. For now, just hide this, and we have something like this. You can increase or decrease the element size, right? And we have this offset. You can choose anything you want. You have to play with this because it needs time to get a desired result you want. You can now create a VolumeNoiseFOG, another VolumeNoiseFOG, and you can just say 0 centered. So you are applying this noise fog onto this, and you can decrease the element size, right? You can offset this, and you can decrease or increase the amplitude. You will see something like this. So this is a way. And I guess I should end this video here. And I want to tell you something really important here. I am having difficulty creating voiceovers for these videos. I cannot like record. I am doing it like very difficultly because of some issues. So I'm thinking that how would I continue this series? And I have thought about this, and let's say the upcoming videos I would create would be voiceless. You won't see me, or you won't or hear my voice. You won't see me and hear my voice also. So what I would do, I would create a PDF of each step, and I would create the notes in the tutorial also, so you can understand the concepts better. And it would be like temporary. After everything works, I would everything works out, I would continue uh, making the tutorials with me and my voice overs. So I guess this is it for the video. The next video would be voiceless. You would have the notes, and if you are watching till here, then believe me, I will take care of everything. You won't have any issue. So I think that's it for the video, and I will see you in the next one. Until then, take care.